Hello everyone, welcome to the YouTube channel of Koran Labs. In this video, we will have a look at the implementation of DTLS over the MidHaul. One of the most important aspects of Open RAN is the provision of multiple open interfaces, which helps us to establish an interoperable environment. Now, with the availability of these multiple interfaces, it is essential to secure each of them to make our RAN fully secure against different type of attacks. In case of multiple vendor environment, when we have DU and CU from different vendors, securing the interface between OCU and ODU becomes particularly important. In this video, we will explore how DTLS can be employed to secure the mid-haul interface. DTLS or Datagram Transport Layer Security is used for confidentiality, authentication, as well as integrity, ensuring that data has not been tampered with during transit. Now, this is how DTLS will be performed or implemented between CU and DU. We know that we have the F1AP procedure between CU and DU. First, the DU sends client hello message to CU, and this message consists of supported signature algorithms, curve preferences, some ephemeral public keys, etc. To response of this, CU sends server hello message to DU, but this consists of selected algorithms only, which are selected out of the algorithm list cipher suits provided by DU. It will also send ephemeral public key, and in case of no server hello message or an unsuccessful server hello message, CU will retry to send a message. Then there will be certificate exchange between DU and CU. After the certificate request and the server hello done, we will move on to certificate verification. These certificates will be used for authentication between CU and DU before any message are sent between them in encrypted form. Now let us have a look at how CU and DU will run and how certificates are exchanged between them. So first we will start CU. You can see the logs here. First, you can see the SCTP has been initialized. We are running DTLS over SCTP. You can see the AMF has been registered. And these are the SCTP related information. Further, F1AP has been initialized. And for authentication in DTLS, we need certificates. You can see the certificate related information here. And these are the certificate signature that will be needed. And you can further see that the SSL server has been started. Now let us run the DU. So here you can see that DU has also started. So the F1AP has been initialized. You can see that the SCTP is working fine. Similarly, like CU, it also needs certificates. So those have to be loaded. And over here, you can see the certificates are loaded. This is the DTLS version. You can further see the SCTP related information over here. The F1AP setup request sequence, which was initialized, is now successful. These are the DTLS handshakes that are performed on DU as well as CU side. And this is the DTLS session. You can see the cipher session ID, the master key required for handshake. And this over here is the DTLS session ticket. This is basically how a session ticket looks like. Now, this is the verification return code. In this case, or in our case, we are using certificates. So these certificates will be verified mutually and the data will be sent over F1AP in encrypted form using DTLS. And you can see all the cipher suits available on the DU side. And then again, you have the F1 setup response, which is successful from the Koran Lab CU. So similarly, we have some updated logs on CU side, like the F1 setup request information over here. These are the cipher suits and handshakes. Similarly, are performed on the CU side as well. Now we move to our lab. You can see the radio light is currently blue. Now we will be running our RAN. Once our RAN stack is running, you can see the light turns to green. And now we are in a position where we can connect our UE. We have to remove it from the airplane mode. And over there, now you can see that it is connected to our network. You can see the 5G symbol over there. Now to test this end-to-end connectivity, we will check if our internet is working. So this basically will establish that we have achieved end-to-end connectivity. Similarly, we can elevate the MidHaul security even further by introducing post-quantum cryptography. By implementing PQDTLS over the F1AP interface, we can ensure resilience against future quantum-based threats. This will be the focus of our next video, where we will demonstrate how PQDTLS can secure F1AP, making our RAN more robust and future-proof. That was all for today. Thank you so much.